All right, so today we're going to just review, because this is honestly a review. You've seen how to graph a quadratic equation in standard form, whether you were in middle school or whether you were on campus with us when you were learning quadratic equations in Algebra 1. So what we're going to do is we're going to graph this by hand. You won't need a graphing calculator, so I'll tell you that now. Okay, so for the first part, it says that you're going to learn, it's not really learn, but you're just going to review how to solve or how to graph quadratic equations in standard form or quadratic functions, and you're going to find the domain, range, and your end behavior, which we've already talked about, honestly, earlier in semester 1. So the first thing we're going to do is look at this equation. This equation here is standard form. This a value in front of your equation represents what happens to your graph. Specifically, if your graph is going to open up like a cup or if it'll open down like a frown. So if this a value is greater than 0, that means that your graph is going to open up, which is a minimum. So opens up. That means your graph is a minimum. And let me actually write out minimum. It's a minimum graph, which means the graph is going to open up like a cup. If your graph has an a value, so this leading coefficient in front, if it's less than 0, that means the graph is a maximum. Let me actually fill in an a. So if it's greater than 0, this is a minimum. If it's less than 0, it's a maximum, which means your graph is going to open down like a frown. So using the a value information that we already hopefully remember from Algebra 1, we're going to review the different steps on how to graph it by hand, and then we're actually going to graph it by hand. So on this first page, I'm just going to graph the first equation over here in the middle. So I'm just going to kind of move that to the side. And we're going to look at some steps. All of the items on the left are your steps. So to find your vertex, which is extremely important in finding a parabola, is going to be finding your x equals negative b over 2a formula, and then plugging in your x value into your function to find y. Okay, so let me kind of ask you guys two things before we move on. What's a vertex? If you have a parabola, for instance, this little shape here, let me actually graph it here. Here's your little shape. Here's your parabola. Where's the vertex? Desiree, I feel like you're going to say something. Where is it? In the middle, down here? Yeah, that's exactly it. That's your vertex, that little point. So to find your vertex, which is that point, that Desiree just helped us with, that's what we're trying to find. So to find that little point, you're going to use this formula. Bonus points in my head for you. What is that formula that I just boxed in black? What is it called? Begins with an A. I'll give you a hint. If you cut the parabola in half, you'll have 2 equal pieces. When you cut something in half and have 2 equal pieces, what's the S word for that? Symmetry. Okay, so it's something of symmetry. Begins with an A. Axis. This is your axis of symmetry. Good job. Axis of symmetry. That's that equation that I just boxed in black. What the axis of symmetry does is if you literally took some scissors or a knife and you cut this parabola into 2 equal pieces, you would literally have the left-hand side and the right-hand side being the exact same. What that also means is if you folded this paper along this dashed line and you had it reflecting onto the other side, they would both line up exactly. So that's what an axis of symmetry is. It literally cuts it into 2 equal pieces for your parabola. So this whole part for steps 1 and 2 is finding your vertex. That's going to help. Step 3 is looking at your a value. We just said this before. Michelle, what did we talk about for the a values again? There were 2 different types of parabolas we could have. What are the 2 types? Minimum or maximum. So this a value tells you if your graph is going to be a minimum or a maximum. So that a value is going to tell you if you're going to have a min or a max. I'm going to scroll down a bit. We are going to label domain, range, and end behavior. We're not going to worry about that now. I'm just going through the steps. Step 4, which I'm going to label here, is your y-intercept. How do you find a y-intercept? What do you have to do to find a y-intercept? Alex, take a guess. We know it needs to touch the y-axis. So how would you find a y-intercept? What do you plug in to an equation to find your y-intercept? Okay, plug in. What are we going to plug in for x? What number? Help him out. 0. Plug in 0 for x. You're going to plug in 0 for x. When you plug in 0 for x, guys, that's always going to give you your y-intercept. So when you plug in 0 for x, your 0 is your y, or x, excuse me, 0 is your x value. Y would just be whatever you find. And then the last step, for step 5, is finding your x-intercepts. Okay, well, hopefully you remember, if you plug in 0 for x, you'll find your y-intercept. If you wanted to find an x-intercept, you would need to plug in or substitute 0 for y this time. You would plug in 0 for y, and you would solve. There are, based on what we did several weeks ago, probably recently, maybe a couple weeks ago, we talked about how to solve a quadratic equation. There are 4 different methods that we talked about last time we saw this that will help you solve a quadratic equation. What are the 4 types of solving you can do? Go ahead. Completing the square. Give me another one. Factoring. That's all right. You got 2 out of the 4. Yes, ma'am. Square root method. There's one more. Michelle? Not quite. Difference of square is a type of factoring. That's not a method of solving per se. There were 4 major types. Quadratic formula. There you go. Quadratic formula. So those are the 4 different types. I don't care which method you use. I just want you to solve it. So for instance, just because I already know some of y'all forgot how to factor between the last time I taught it and now, so I want to actually see, since we were going to find x-intercepts, which we'll eventually have to do for this question, I need to plug in 0 for y, and we're going to solve. So 0 for y, and we would solve. But the issue is, I don't think y'all remember how to factor. So let's flip it over to the next page. Before you start factoring it, let's flip it over to the next page. There are 4 different types of solving. Factoring should be able to be used for almost every question that you solve. So let's go ahead and look at the next page. There's methods to my madness, guys. I want you guys right now to show me that you didn't waste the last couple of weeks of school, and I want you to show me that you know how to factor this guy and this guy at the bottom. Questions 3 and 8. So right now, I'm not doing it. I will give you a hint, though, for both of the questions. Factor out your GCF first. Factor out your GCF first. Remember, you are factoring the trinomial and then solving. So once you factor it, solve it. Set it equal to 0 and solve. All right, let's see what you guys got. For question 3, Nicholas, what was the GCF for question 3? 5. Okay, you could factor out a 5 from both of those terms. Any variables? 5b. Cool. So when you factor out that 5b from both of these terms, what's left over in the parentheses, Nicholas? Perfect. Guys, once you factor out the GCF, if you can factor something out first, do that. Once you factor that out, Nicholas, what can you do from here? Try to find B. How are you going to find B? Okay, so what we're doing here, what you're technically telling me, is we need to use what's called the zero product property. Zero product property means you need to take 5b, set that equal to 0, and then take b minus 2, set that equal to 0. By the zero product property, you split and set each of the binomials, monomials, whatever the polynomial is, equal to 0 and solve. So that's exactly what we're doing. So in order to solve, I'm going to divide both sides by 5 first. So b is going to equal 0. That's one of the x-intercepts, or one of the b-intercepts. And then I'll add 2 to each side. So b is going to be positive 2. These two answers are what you should have found. B equals 0 and B equals 2. Those are your two answers. I am notorious, guys, for giving y'all questions like this on your tests and quizzes and expecting you to factor it. Please make sure you remember how to factor questions like number 3. For question 2, Tristan, what was the GCF that you were able to factor out from here? Let's try that again. From question 8? You factored out a 12 from each of these? 2. Okay, there we go. That's going to leave in parentheses x squared plus 12x plus 36, which should still be equal to 0. Tristan, at this point, am I done? Can I just set that equal to 0 and just, quote, solve? Or can I do something else? Only time you could take out an x is if each of these, including the 72, had an x. We're done with the GCF. We can't take anything else out. You see how there's 3 terms in the middle of this? Let's try to factor it like we did a couple weeks ago. So what I'm going to do is I'm going to make my little x chart. Some teachers use a little t chart or some other way in order to factor. I just use a little x chart. I need to find 2 numbers that multiply to what, Tristan? 36, but add up to what? Okay, so you tell me. What 2 numbers will multiply to 36 but add up to 12? 6 and 6. So my last question to you is, what would the factors look like if I actually factored this out? There's 2 binomials I need to create. What are they going to look like? Not x plus 12 and x plus 6. What were the 2 things you just found? 6 and 6, right? Yeah. We're going to make this x plus 6 for the first one and x plus 6 for the second one. We're going to set that equal to 0 and we're going to solve. If you were to FOIL this out, you would get the exact same expression right up here. Is this okay? If this is confusing for you, the videos that I made in the past over factoring, you should definitely rewatch those. The last thing I need to do, again, like I said with Nicholas, is by the zero product property, we're going to take everything that has a variable and we're going to set it equal to 0. The 2, does it have a variable with it? No. So we're just going to rewrite x plus 6 equal to 0. And the other, x plus 6 equal to 0. This 2 in the front, we don't need to solve. It's already kind of, quote, solved. We don't need to do anything else with it. So all I need to do is just solve. I'm going to subtract 6 on each side. So x is going to equal negative 6. If I was to solve this one, what would you get? X equals negative 6. It's the exact same thing. You don't need to solve both of them, guys, but you can. Your only answer that I'm looking for is just any of the x equals negative 6. That's it. Give me some nods or shakes. Does this refresh your memory as to what you should remember from factoring? Cool. If it doesn't, all of the rest of these questions, you're more than welcome to solve at a later time. I, however, am going to finish the notes that we had in front of us from the first page. So let's go ahead and flip back to that front page. And let's finish finding the graph for this. So to solve the equation that I have here, the first step says to find my vertex. Okay, so first thing, to find your vertex, we need to use this formula that I boxed in black to find your axis of symmetry. I get lazy, so I'm just going to label AOS for axis of symmetry. If you write that on a test or quiz, I'm okay with it. AOS, I just put as axis of symmetry. So I need to take the equation here. I'm going to label my A, B, and C, and then plug it in. So if I was to plug in my numbers, Andrea, what's the A value? What's the A value for this? In this equation, what's the A? Okay, so what's the number in front of x squared? 1, good. What's the B value? What kind of 2? Not just the x. What sign? Negative 2, and then what's the C value at the end? What kind of 8? There you go. Take each of those values and you're going to substitute them in. So x is going to equal negative B over 2 times a. Notice that I use parentheses, guys. Y'all are all in high school. You shouldn't need me to tell you this, but use parentheses when you plug this in. We're going to plug in negative b over 2 times a. When I do that, I'm going to notice that the numerator, negative times negative 2, is actually going to turn positive, and the denominator, 2 times 1, is going to stay 2. Most of the time, about 80 or so % of my students will mess up that numerator because of that stupid negative. Please don't be the person that has to lose a point on your test and quiz. When you simplify everything, the axis of symmetry is just positive 1. X equals positive 1. Notice that I wrote x equals. If you don't put that x equals on tests and quizzes, guys, it's not the correct axis of symmetry. It needs to be an equation. All right, step 2, if I look here, says to find the x value, plug the x value into the function to find y. What I'm actually finding is my vertex. My vertex, as you can see here, is a coordinate. It's an x and a y. I need to take this x value that I just found. We're going to plug it in here for the x coordinate. And now I need to find my y. To find my y, I'm going to plug in that positive 1 into the original problem. I always use my little parentheses to plug in things before I start putting the numbers in. All right, let's simplify. I'm technically going through PEMDAS when I solve this, but this question's actually pretty easy. The P stands for parentheses. There's nothing going on inside the parentheses with those ones. E stands for exponent, so we're just going to do 1 squared, which is just 1. M and D means to multiply, so I'm going to do 2 times 1, which is going to give me negative 2. And then from here, I'll just add and subtract. So we'll have 1 minus 2, which is negative 1. And negative 1 minus 8 is negative 9. Brooks, what did I just find? I know I got a negative 9, but what is that? The y value for your what? Begins with the V. For the V. Vertex, there you go. Negative 9. That is a negative 9. That's my vertex. So, based on this and based on what Desiree told me earlier, that's going to be at the very bottom of my graph or at the very top of my graph if it's opening down. So let me graph what I have. I'm going to use my light blue pen and I'm going to graph 2 things. X equals 1. I always graph my kind of vertical line slanted so that way you can see it. And then I'm actually going to plot the point 1, negative 9, which is down here. Okay, next step, we need to find the a value. So step 3 says to determine the a value. If we look back at the top, Andrea told us that a is equal to positive 1. So if a is equal to positive 1, based on the information we have here, is it going to be a minimum or a maximum? Minimum, which means it's going to need to open up. So I'm just going to put min for short, and you need to remember that this opens up. Okay, so if I was to open this graph in an upward direction, it's probably going to touch the x-axis 2 times. So let me finish up the rest of the problem so that way we can see exactly what the graph is supposed to look like. Okay, for question 4, or step 4, it says plug in your 0 for x. So in the original equation, x squared minus 2x minus 8, we're going to plug in 0 for x. So if I was going to plug in 0 for x, we're going to have 0 squared minus 2 times 0 minus 8. Chris, what's 0 squared? 0. What about 2 times 0? 0. So what's your y-intercept? I'm going to write this as 0, negative 8 as a coordinate because I don't want you to get confused and say, wait, Miss Tapia, this is part of your vertex. No, this is the y-intercept. So 0, negative 8 is your y-intercept, and I'm going to plot that on my graph. 0, negative 8, that big blue dot. Last thing I need to find is the x-intercepts. Omar, how do I find the x-intercepts? Plug in 0 for y, and we need to solve. Well, we practice on the last page factoring, so I want all of you guys, not just Omar, but all of you guys to try to factor this. Once you factor it, find the x-intercepts and graph it. That's all you have to do from here. I'm going to give you about a 30-second head start. So we need to find two numbers that multiply to -8 but add up to -2. The only two numbers that I can try to find, I think, that will multiply to that is going to be 4 and 2. Let's make the 4 negative. Is that good with you guys? Okay, cool. So since my leading coefficient in front of x squared is a +1, I can just rewrite two binomials as x minus 4 and x plus 2. Once you find both of the factors here, as long as your leading coefficient, which is the a value, is a +1, you can always do this. I'm going to set it equal to 0, and I'm going to solve. So we're going to take x minus 4 equal to 0 and x plus 2 equal to 0. Okay, so one of the x-intercepts, which I'm going to write as a coordinate, is going to be 4, 0. That's one of the x-intercepts. The other x-intercept, oops, actually write that as a coordinate, is going to be -2, 0. Those are your two coordinates. When you plot these graphs on your paper, you want to make sure that you at least have about 5 points when you're graphing it, because your homework tonight is going to ask you to put at least 5 points. So on this graph, I right now have 4. Where could I get another point from? I need to have at least 5 points for this. Where can I get another point? Carol, where can I get another point for this? How'd you get 2, -8? That's a very specific point. How'd you get that? To what point on the right hand, or excuse me, the left hand side? To 0, -8. She said we could use the point 2, -8, which is right here. She's absolutely right. What I would do is I always tell my students, okay, well, we know that since it's symmetric, which means it's going to be equal on each side, they're both going to be the same. I know that the x-intercepts are going to be on the same side, just equal distance apart. And so will technically the y-intercept. Okay, well, the y-intercept doesn't have another y-intercept on the right-hand side. So what all I tell my students to do is count how many units the y-intercept is from the axis of symmetry. Well, it's only 1 unit away. So on the other side, the right side of the graph, I'm just going to go 1 unit from the axis of symmetry and plot that as a point. 2, -8 is the coordinate that I want to use. So I'm just going to curve this graph going up, and I have my function. That's it. It seems like a lot and seems tedious, but I want to make sure you have a thorough understanding of what you're supposed to be doing. So make sure you have that graphed out, and please make sure also that you actually extend this line going up the same way I did. Make sure that you have that, because it'll help you with the last thing we're going to cover, which is the domain, range, and end behavior. So down here in this section, very bottom margin, I'm going to write the domain, the range, and the end behavior. Let me zoom out a bit. So I have the domain, the range, and the end behavior. All right, so looking at the domain, you can give it to me in interval notation, because that's what you guys probably like best. What's the domain for this blue graph? Read it from left to right. What's the domain for this blue graph? Negative infinity to positive, which is the same as all real numbers, in case you wanted to write it that way, all real numbers. Mia, try the range. What's the range? -9. So that goes from the bottom of your graph to the top. Yes, that's exactly it. -9 to positive infinity. I know the infinity, Mia, has to have a parentheses, but what about the 9? Bracket. Since this is a closed circle down here at -9, yes, we need to put a bracket. Good job. Okay, for the end behavior, last part. As x approaches positive infinity, as x approaches negative infinity. I need to know what's happening to the y's. So if we look at the graph, as the x's on this x-axis continue to get bigger on the right-hand side, the graph is curving up. If it's curving up in this direction, where are the numbers going to? I know they're going to go to 10, but what's past 10? If we keep going up the y-axis, positive infinity. So as x approaches positive infinity, y also approaches positive infinity. The same thing should happen for as x approaches negative infinity. On the left-hand side, as you look at the x values here, as the curve continues to go to the left-hand side, the y values are going to keep getting bigger along the y-axis. So your y values should also be going to positive infinity. Fun fact about parabolas, whatever your end behavior is for your y values, they should both be the same. For parabolas, they should always be the same. All right, I'm going to do one more question with you guys, but a little quicker since you guys have already kind of gotten the hang of this a little more. And after I do my question, you guys are going to do one by yourself. So flip it to page 3, and I want you to try to start off question 3, because that's the one I'm about to do with you. So I'm not going to lie, I know how I write. I'm probably going to need some more space, so I'm actually going to use the backside of my page to solve this. You can continue to use the box, but I'm going to use the backside of page 3. So y is going to equal 2x squared plus 4x minus 6. I know you're looking at this like, oh, Ms. Tapia, I could factor out a 2. Okay, cool, but don't factor out the 2 just yet. I'm going to follow the steps literally from the first page, and I see some of you guys flipping back and forth, which is awesome. We're going to look at step 1 first, which is using the axis of symmetry formula. So over here, step 1, AOS for axis of symmetry. In order to find that axis of symmetry, I need to label the A, the B, and the C. A is going to be positive 2, B is 4, C is negative 6. Okay, the axis of symmetry formula is negative B, which in this case is 4, over 2 times A, which in this problem is 2. All right, let me simplify. So that'll be negative 4 over 4. And negative 4 divided by 4 is just negative 1. Remember, axis of symmetry, guys, is an equation. So make sure you leave it as an equation when you box it. Don't forget that equal sign. Step 2 is to find your vertex. It's going to bother me. All right. Part 2 is to find your vertex. The x value from your axis of symmetry is the same as the x coordinate for your vertex, so just recopy it. What do I do to find the y again? Plug it in. We're going to take y equals 2 times negative 1 squared plus 4 times negative 1 minus 6, and we're going to plug it in. I am literally going through, I did this on the last question, I'm using PEMDAS to simplify. P stands for parentheses. There's nothing happening in this parentheses besides that negative 1. E stands for exponents. Let's square this. Y is going to equal 2 times 1. And I just recopy the rest because negative 1 squared is just positive 1. Next, we're going to multiply and divide. Okay, so I just need to multiply 2 times 1, which is 2, and 4 times negative 1, which is negative 4. Last thing I need to do is add and subtract. So 2 minus 4 is negative 2. Negative 2 minus 6 is going to be negative 8. Brooks told me on the last question, this value that I just found is not the y value or y coordinate or y intercept. It's just the y value for your vertex. So let me plot the things that I have so far. I have my vertex and I have my axis of symmetry. So on the front side of this page, just really quickly, I'm going to plot that. So we're going to start with negative 1, which is here. And I'm going to plot the point 1, negative, that's 7. 1, negative 8, which is here. Make sure as you're writing this stuff out, go ahead and plot the points. All right, continuing on, if I look back at the first page, it said step 3 is to determine what your A value is. So for step 3, my A value is positive 2. If your A value is positive 2, is that going to be a minimum or a maximum? Minimum, which means your graph is going to open where? Opens up. So I have that little image in my head. It's going to open up. Step 4 is to find the y-intercept. Okay, well, to find the y-intercept, we're going to take the equation. And we're going to plug in 0 for every x that we see. So we're going to go ahead and do 0 squared, which is just 0. We're going to multiply. I'm literally just using PEMDAS, guys. Parentheses, there's nothing inside, just the zeros. 0 squared is just 0. M and D, when I multiply 2 times 0 and 4 times 0, those cancel. So my y value is just -6. Wait, is this the y value for your vertex, or is this something different? What is this? Your y-intercept. So make sure you write it as a coordinate so that way you see that it's the y-intercept. So I'm going to go back to the front side of the page just really quickly to plot this little point, 0, -6. The last thing that I need to find, step 5, is your x-intercept. So I need to take the equation and set it equal to 0. If you can factor out a 2, factor out that 2 before you solve. So let's see, for this question, we can definitely factor out a 2. So we'll have 2 x squared plus 2x minus 3. I don't know about this. This looks kind of weird. If I try to factor this, are there two numbers that will multiply to -3 but add up to 2? Which numbers can we use? -1 and 3. Okay, that does work. -1 and 3. Cool. Since I factored out that 2, I don't need to worry about factoring by grouping. I can just rewrite, since its leading coefficient's 1, I can rewrite my problem as 2, x minus 1, and x plus 3. Since this leading coefficient is 1 that I factored, I can just rewrite both of these as an x plus and an x minus, whatever the signs are. Last part is to actually solve. So we're going to take each of these and set them equal to 0. And again, we are finding the x-intercepts. That's why I labeled it that way. On the front side of this page, I'm about to plot both of my points, 1 and -3. All right, so here are my points. +1, -3. Remember, you want to have at least 5 points on this graph, so I have 4 total. Like Carol told us before, if we just reflect the y-intercept across the axis of symmetry, we'll get another point. So this is 1 unit away. I'm just going to reflect this 1 unit on the other side. So I have my parabola. So I'm going to try to curve this the best that I can. It's not going to be the most beautiful graph, guys, but it'll be close. It'll get you points. That's my curve. Normally, especially if we had like more time and everything, I'd go through again the domain, the range, and the end behavior, but we've already kind of done that a lot at the beginning of first semester, so I don't want to waste too much time on that. What I do want you guys to waste time on is doing question number 1 at the top of the page. So right now, look at question number 1, y equals x squared minus 4x plus 6. That's the question I want you guys to do right now. They give you guys about 3 minutes. So I've noticed that you guys have x equals 2 as your axis of symmetry. You have the vertex, which is 2, 2. You hopefully know that the graph is opening up because a equals 1, and you have a y-intercept of 6. Just take a second and look up while you guys are frustrated with solving for the x-intercept. Do you need to really find the x-intercept for this question? The reason why I ask is because, remember how we said a equals 1 is a minimum? Minimums open where? They open up. So if this graph is going to be opening up, we already have the vertex, we already have a point that's going to be on that curve. It's just going to open up this way. If that's true, is it going to ever touch the x-axis? No. Remember, there are 3 types of solutions for quadratic equations. No solution, 2 solutions, and 1 solution. We did this several weeks ago when we were talking about solving quadratic equations. So for this question, for step 5, you can put that there are no real x-intercepts. There might be some imaginary ones, but I don't need the real or the imaginary ones. I just want the real x-intercepts. So all I'm going to do from here is curve this graph going up. I know I said I usually like to have 5 points, but for this question, we really just need about 3. So I have the left-hand side over here, and thanks to Carol at the beginning of class, I can just reflect this point 2 units on the other side and connect this graph going up as well. That's your graph. That's all you have to do. Last 3 questions, and then I promise I'm done. We're going to go ahead and look at the last page, and we're going to start out by looking at question 3 at the top of that page. So we're going to look at the last page, question 3 at the top of that page. Okay, so for question 3, which is this guy, it says we need to convert this from vertex form, which we'll talk a lot more about next class. That's an A. Let me make this a prettier A. We're going from vertex form into standard form, which I'm going to write in green, which is ax squared plus bx plus c, which we've been dealing with all day today. If I ask you to convert from this disgusting, ugly form, which is actually my favorite form, by the way, if I ask you to convert from this ugly, disgusting form into standard, what would you do besides stare at the board and look at me? Which is what y'all are doing now. What would you do? Go ahead, Alex. What do you mean x plus 7 squared? What does x plus 7 squared mean? You would have to FOIL it. X plus 7 squared means that you're going to have y equals negative x plus 7 times x plus 7 plus 49. I just expanded that squared. Once you do that, you're going to do just like Alex suggested, and we're going to FOIL this. So we're going to make this y equals negative x squared plus 7x plus 7x plus 49. Notice this is all inside your parentheses. And at the very end, remember this plus 49 that we had from the original problem? We're just going to add it to the very end. Of course, we need to clean this up a bit, but it almost looks like standard form. How can I simplify this even further, though? Go ahead. Multiply everything in the parentheses by a negative. Let's distribute that negative sign. So y is going to equal negative x squared minus 14x minus 49 plus 49. Last thing we need to do is see if there's any last things that we can combine. I see a negative 49 and a positive 49. Can I combine those? Yeah, we can combine them. When you combine both of those, though, what happens? They cancel out. That's your answer. So, we've gone through a lot of things today. I talked to you guys about how to graph. We talked about all the different pieces for graphing in standard form. The last thing that we haven't really talked about yet is this kind of vertex form that I just kind of introduced with the problem above, which you did see back in Algebra 1. What I want you guys to do, just for the purposes of kind of finishing up our lesson for today, we're going to do questions 1 and 2, and we're going to solve this by the square root method. Questions 1 and 2 are the only two on this bottom portion of your page that can be solved by the square root method. When you're solving by the square root method, we did this in your notes. If you look back in their notes or the video I made, it specifically tells you to isolate the x squared. So in order to solve, you need to isolate your x squared. Tristan, looking at question number 1, how would I do that? How would I solve this disgusting mess that I have? I'll give you a hint. Don't FOIL. Didn't I just say don't FOIL? Don't distribute? Don't do it. Remember how it said isolate the x squared? Don't touch the x squared. What's the only other thing that has to move from here? The 20. So how would I move the 20? Okay, let's start there. That's a better start. Let's start with 20. So we'll have x plus 2 squared is equal to 20. Guys, don't try to FOIL this. Don't try to distribute. This can be solved by the square root method. This is how. Tristan, once you get to this point, what can you do? Square or square root? Square root both sides. When you square root both sides, you'll have x plus 2 on the left, and then you'll have to simplify the square root of 20. We've been simplifying radicals for a while now. You can break this into 4 and 5. This is just kind of like, I guess, a quicker way for some students. What's the square root of 4? 2. So you can rewrite this as 2 square root of 5. What am I missing here? Plus or minus. I square rooted both sides. Y'all know I'm quick to take off a point for any and every reason. Squeeze that plus or minus in front of that 2. Tristan, last thing. You're almost done. How do I get the x completely alone? Subtract the 2. Let me ask you this before I stop bothering you. Can I cancel these 2's here on the right-hand side? I was about to say, don't make me be mad at you. Thank you. We're going to make this negative 2 plus or minus 2 square root of 5. That would be your answer. Don't say, oh, Miss Tapia, we could just cancel these. Don't cancel. Please don't. All right. Your task right now is to finish question 2. So right now, do question number 2. Use the same process that we just did. So really quick, guys, just for question 2, make sure that you have your answer the same as mine. For question 1, though, I just want to make sure that you understand these square roots. This is technically what I was doing. I was taking the square root of 4. That's how I got 2. So 2 square root of 5. We're still going to do like the prime numbers thing that we did earlier in the semester, but we're going to save that really for more things later on. But if you have questions like this that you want to do that little tree for, you can definitely do that.